Today I'm looking at an MPPT solar charge controller from Renogy, and one of the main reasons I bought this item was because I get quite a lot of recommendations about the Renogy brand, and I've never actually looked at one of these solar charge controllers or held it in my hands. Now I think most of the people who recommend it are from the US, and that is probably because Renogy is a US brand. Now, apparently it was born from a project at Louisiana University, I believe, which has now turned into a product and a range of products, because there's quite a lot of different solar charge controllers badged by Renogy. But before we open this box, let's take a look at a couple of the key features. This is a 12 or 24 volt solar charge controller. It's got high tacking efficiency of 99%, presumably that means tracking, peak conversion efficiency of 98%. Well, I'm not sure I'm going to be able to fully check those numbers, but we'll see. 4-stage charging, extensive electronic protections, diverse load control, LCD screen with programmable charging parameters, but I think you need an optional accessory to change those charging parameters. We'll store data up to 1 year, which is nice. I like to get stats out of my solar charge controller, and that seems to be done over an RS232 port, which can connect to a Bluetooth module. It also mentions about lithium iron phosphate in there as well, so this seems quite fully featured. So I've got all the items out of the box here. We've got the solar charge controller itself, a decent manual, I have to say. There's lots of pages of it. There's 30 pages, and that is all in English language. There's a remote temperature sensor which is included, some brackets to help you mount this solar charge controller, and of course the solar charge controller itself, which is quite a nice looking thing, I think. Comparing it to the EP Tracer range, which is the one I have the most experience with, I think the screen is ever so slightly taller, but probably about the same size. 4 buttons on here, so perhaps there are enough buttons to actually be able to change the charging parameters. We'll find out in a bit. 4 LEDs at the top, one indicating solar, one indicating the battery status, one for the load, and an exclamation mark and a triangle, which presumably indicate errors. Moving further down, we've got the screws there, which will actually take a posi drive or a straight screwdriver in there. On the bottom, we've got the connector for that temperature sensor, the PV plus and minus, the battery plus and minus, and the load plus and minus, very conventional. On the right hand side here we have the RS232 port, which seems to be an RJ11 or RJ12. There's only 6 connectors in there. So not an RJ45, a normal network cable, as is used in the EP range. So one day I want to be able to interrogate that port and see what information I can read from this solar charge controller, so I will need to find an RJ12 or 11, I can't remember which one it is, connector for that. But yes, that's it's a decent haul inside that box. I've opened up the manual at the technical specifications. As you can see, I'm using the 20 amp model, so it claims a maximum of 260 watts at 12 amps, but actually the Renogy website goes on to say that it's a maximum of 20 amps charging current to the battery, not a limit on the input. So you could potentially attach a solar array that could create more than 20 amps on the input, and that might be useful if you want to maximize your charging in the winter, but you will also of course lose some of that solar power in the summer. The cable size for my 20 amp version here is 8WG, but apparently that's the same on the 30 and 40 amp versions as well. Self-consumption, 100 milliamps or less than 100 milliamps, which seems a little bit high, but I guess there is an LCD and a few LEDs to power on this particular charge controller. In the section on the right hand side, we can see the charging parameters for gel sealed flooded lithium, or LFP, LiFePO4 I'm guessing, or user. And I'm a bit surprised. Look, it says battery charging parameters in lithium and user mode can be programmed using the Renogy BT app, Bluetooth app, because of the Bluetooth additional component you can buy. And I think that's a bit of a shame, because I think with 4 buttons you should be able to adjust the lithium and user profiles, but this seems to suggest that you can't, which is a shame. I usually attach my solar charge controllers to an AGM battery for testing and choose the gel profile where possible, which this is going to charge up to 14.2 boost voltage for 2 hours before dropping to 13.8 volts float voltage, and it's got some undervoltage protections on here, of course. Low voltage at 11 volts and discharging limit voltage 10.6, so presumably the load turns off at 11 volts. Again, possibly a little bit low for me. Right, time to open up the Renogy Rover PG, and as normal there are 4 screws on the back of this thing, and will that screwdriver get through? Yes, it will. 4 screws and we'll be in. Right, finally I think I'm in. It was the temperature connector that was causing me the problem. That's clearly got a wire on there, so the LEDs are connected through this wire. That looks like a connector I could disconnect though. Yes, it is. Brass inserts in the plastic case, so that's a nice touch. So much as I would expect from a reasonable brand MPPT solar charge controller. A big inductor up here which is sort of potted in a cup and then presumably thermally glued onto this heatsink. Or is there a screw in the back? Yeah, there are a couple of screws going into these points here, so that's screwed down and hopefully there's some compound in between them. A extra PCB which is on these standoffs to bring the LCD and the buttons up to the front of the case, and I think I just spotted what is probably the main microcontroller over there, which is underneath that PCB, so that's going to be very difficult to get any information from. The wire going up to that inductor is 10 AWG, but that's been bent round the corner a bit, that one, hasn't it? But I'm sure it will be fine. Down here there are 3 screws going through the PCB using these clamps, presumably clamping some MOSFETs or diodes under here to the heatsink. Yeah, so keeping the main diodes and switching MOSFETs cool is always a good idea. That is a 40 amp fuse, and of course this was the 20 amp MPPT solar charge controller, so that is very much a fuse of last resort. Of course you really do need a fuse or a trip switch on your MPPT solar charge controller between that and the battery, and that is, well, one of last resorts. 40 amps on a 20 amp solar charge controller. Input caps, which I can see there, are labelled 100 volts, 330 microfarads, so presumably you can put close to 100 volts of solar on the input of this MPPT solar charge controller, which then, using the diodes on the bottom of this PCB and the inductor, convert that 100 volts down to 12 or 24 volts for your battery. So yeah, that's pretty much it, much as I would expect. Let's put this back together again and give it a go. For this test, I'm going to be using this 17 amp hour 12 volt lead acid battery, and as you can see, it's got a bit of a load on it here. That 18 watt bulb has been sat on there for a couple of hours, so this should be reducing in voltage quite well. I also have a couple of other lamps I can add. There's a 20 watt 12 volt bulb and a 21 watt 12 volt bulb as well, so all in all I get about 50 watts of load here if I need it. I'm going to be attaching two 100 watt monocrystalline panels to the Renogy Rover, and that should provide, well, up to 200 watts. Obviously I'll be connecting them in series, which means I should have an open circuit voltage of about 42 volts and a maximum power point around 35 volts. And of course that 35 volts will be brought down by the DC to DC conversion to the 12 volts that is needed for the battery. It's worth mentioning the sun isn't at its strongest today. It's a little bit overcast, so this might be a test of how well the Renogy Rover works in low sunlight. But without further ado, I'll take this battery off the desk, wire everything up, and we'll give this charge controller a test. I'm trying a different camera angle today so that we can see all the LCD screens. Let me explain what we've got. A quarter-pound meter on the left here. This is going to show us the voltage and the current from the solar panels. Remember, that's 200 watts of panels, two 100 watt panels in series, giving me an open circuit voltage of about 41, 42 volts and a maximum power point somewhere around 35 volts. It's not the best day out there today, but hopefully we'll be able to see 50, 60, 70 watts, something like that. On the right hand side, the quarter-pound meter is going to show us the battery voltage and the current going into the battery, and hopefully obviously in the middle we'll be able to see some information. So without further ado, let me connect up the battery, which does have a decent load on it with all those lamps there. The Renogy has booted up and it's saying 12.2 volts, which is pretty much agreed with by the quarter-pound. That's a good start. 63 milliamps being drawn there from the battery by the solar charge controller. So that is less than 100 milliamps, isn't it? As claimed by the manual, 63 milliamps, and that seems to be fairly constant. Okay, let's plug in some solar and see what happens. That goes in there. We can see we've got 41 volts on the input there. No current, well, negligible current at the moment is flowing. The charge controller seems to have illuminated that sun icon, so it knows that there's solar coming in, but nothing yet is happening. Now it starts to find some current and adjust the load on those panels. And is that settling out? Yeah, it's settling out in the mid 30s. We're getting, 33 volts currently and 1.1 amps. That's 35 watts. And on the right hand side we can see that the battery voltage is increasing, and there is 2.5 amps going into that battery, 33 watts currently. So yes, we're definitely seeing DC to DC conversion, 32 or 33 volts at 1.1 amps being converted into 13 volts at 2.5 amps, and it seems reasonably efficient. We're losing a few watts in the conversion. Now, to help us get to a higher voltage on this battery and see what happens on the meters, I'm going to reduce the load on that battery, remove some of those lamps which are connected to help. Oop, that one's hot. And that should help the battery voltage rise up, and hopefully we should see that go into equalization or boost mode. And the voltage has risen up now to 14 volts, 14.1. I don't actually know which battery mode this is set to at the moment. I haven't actually pressed any buttons yet, have I? But it does indicate on the screen, of course, that it is doing MPPT, and as I said, yeah, I'm happy with the MPPT voltage over here under my changing slightly cloudy sky. The battery is now getting up to 14.3 volts according to the Renogy, 14.2 volts according to the Portapow, and it still seems to be sat at the sort of maximum power point. So we'll see how long that lasts for before it starts adjusting its voltage on the input to adjust the amount of current coming in to regulate the battery. 14.2 volts, 2.2 amps going into that battery at the moment. And the screen, I've just noticed, is now saying we are in boost mode, which actually, that's a really nice thing to show which mode the solar charge controller is in on the LCD screen. So it's not maximising the current anymore, it's holding the battery at 14.3 14.3 volts. So we can see on the left hand side the voltage of my panels have now been allowed to increase to reduce the amount of current and therefore the amount of power coming in to just maintain 14.3 volts on that battery in boost mode. So I'm guessing this must be in flooded mode, perhaps. Was it flooded that had 14.3 volts? Well, actually, as it goes, 14.3 volts is none of these. It's 14.2, 14.4 or 14.6. So perhaps it's in gel mode. Shall we start looking at the menu? So taking a quick look at the manual, this button kind of acts as an enter button when you go into a menu, but I think we should be able to go up and down through some menus. Solar panel voltage is 40 volts, that looks about right. The solar panel current, or the amount of current actually going from the solar panel into the battery, 2 amps. Yeah, my meter agrees with that. That's a little bit odd, I think, but anyway. 100% state of charge, I'm guessing that is 14.3 volts on that battery. A small amount of load coming out of the charge controller. Well, that's not quite true because I have nothing connected to the load terminal, so it's showing 100 milliamps of load when it doesn't have any load. Again, what's that? The amp hours, how many amp hours we've had solar to battery and battery to load, and it claims it's about 17 degrees Celsius, which is probably about right. 15, I think that is the code for the load, because like many charge controllers, this will have modes for staying on at an hour after dark, or 3 hours, or 2 hours before dawn, those sorts of things. So I'd have to look in the manual to find out what mode 15 is. That is an error code, and presumably error 0 means there are no errors, which is good. So we've managed to go through the normal screens, not managed yet to get to any sort of parameter to change anything. Press and hold this one. We can now see that we can change the mode, but I'm afraid I really can't see what that actually shows. Right then, I'll do a quick overview of programming the settings. If I press and hold the right hand button, I then go into battery selection mode, and if I move that to user, I can click enter. Then I can choose a 12 or a 24 volt or an automatic selection. Let's see what automatic selection does. I then have the option to change the equalize voltage, so perhaps I might want to do 14, for example. The boost, let's do, you only seem to be able to change it by 0.2 of a volt, but anyway, so 13.8, and the float can also be 13.8 in this example. Is that the, I don't know what that is, over discharge return voltage or over discharge voltage. It's one of those. That must be the over discharge voltage. Well, I said I'd like that to be a bit higher. Odd that you can only change it by 0.2 of a volt, but anyway, that's okay. I can live with that. There we are then. I think that is program. Press the right button, and now that voltage is dropping down because we're above our boost or equalization voltage, or float voltage even, and now my battery is being charged at a much lower level. So that was quite straightforward, wasn't it? Changing the user parameters on the unit itself. As you can see now, it's now in boost mode. Yeah, do you know what? I'm quite impressed with that. You can do a lot more on the screen than I thought you'd be able to do. So there we have a quick overview of the Renogy Rover PG 20 amp MPPT solar charge controller. It's definitely doing DC to DC conversion, and it seems to be tracking the maximum power point of my panels in this short test. There's a good amount of information displayed on the screen, and you're able to adjust the charging parameters using the buttons, not just the communication port. But in the future video, I think I'm going to interrogate that communication port and see what other information I can get out of this solar charge controller. Hopefully you've enjoyed this video. If you did, give me a thumbs up, subscribe down below, comment if you can, and I will see you next time. Thanks for watching.